Hello. Yes. Wow. Oh, a double. Okay, a double. Wow. The first. We're about to be. We're about to be greeted by. Oh my goodness. Okay, hold on one second. Hello.
Hi, you know me. No.
There you go.
Yeah, you know me.
I think they do. Yes. You've been waiting upstairs just to do that. This is your
Yep.
prank. Oh my.
Fools, even though it's not April Fool's.
Okay. It's
Uh-huh.
not- okay.
Got
Oh,
you.
she's saying King High. They're saying hi in the chat thing.
What's the entire thing?
It says King High, which I don't totally. This is the funny class. I mean, but don't tell them they're the funny class. I
What?
mean, that says good afternoon, professor. Oh, she's saying hi. Oh, they're saying hi. They're calling you the professor. Or, oh my God, wait, they're all saying hello and good
There's a
afternoon.
lot of comments.
And they're asking how your Halloween was. Tell them and then
It was awesome. We went with our cousins.
that's true.
My cousins.
Can
He
you
doesn't have cousins.
I have them, but tell
Yeah,
them who
but
you
they
are.
are not fun.
Oh, thank you. That's true. Tell them who you are, and then let me teach.
My name is Felix.
Oh no, I mean, who were you? But
Okay.
yes, you are.
And the dragon.
Yes, you're the Ender Dragon. That is awesome. Some of them probably even get that, but some of them might not. But all
Because
right.
they don't play Minecraft.
Some of them, I bet, they, or at least once upon a time did. I bet.
But they didn't beat the Ender Dragon.
They probably didn't beat the Ender Dragon, unless they weren't.
Unless they were a YouTuber.
Right.
Like I am.
Yes, you are.
Even though my videos suck.
Hey, well, watch your language.
Well, they're bad.
Well, now you're on. Now you just said that to 10,000 people. Okay, so I have to teach, and you.
Not even 100, Dad.
That's true.
Subscribe to my channel, everyone.
That's awesome.
And
All right.
you tell
Well,
everyone
I
my
will.
channel's name.
If I tell them watch out what happens with this class. If I tell them that your YouTube channel,
What?
they'll probably get you subscribed. They're very powerful people in this class.
Please give me subscribers. I need a lot.
We'll get through this exam first. All right.
Now tell them YouTube channel is called,
I
and
will.
then tell them to subscribe.
Okay, I will.
You heard me.
We heard
And
you.
also, that's my fish.
That is your fish. I can't see the fish from here, but all right.
His name is Aquatic.
Yeah, that is true. Awesome. All right. Thank you.
Hello.
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 Huh. Oh wait, can you hear me? Oh wait. Oh, can you hear me? Can you not hear me? Wait a minute. Oh yeah. Okay. Ha! Okay, they said hello to Aquatic. Okay, so they totally can hear us. Okay, awesome, awesome. Thank you. Okay. Yes, that means fish. Okay, sorry, this is not my way of well, it is. Oh, funny. Wow, you guys are funny. Oh my God.
Wow, you're so
Okay.
fast.
Okay, wait.
Faster
Yeah,
than
the Ender. He was the Ender. Okay, wait. Okay, hold on. Wait. Oh my God. Yeah, I mean, are you surprised that I have a son? I have two sons who play my. Okay, all right. So I'm going to go back to. All right, we're going to start in a minute. We're going to start. Oh, well, there's more people coming. Oh, well, they missed all the fun. Okay. Okay.
I can see. I can see. Hi.
Doing well, right? Okay.
Yep.
Okay. All right.
Checking for ammonia.
Good plan. See, it's really clean. Okay, but I do have to teach. Well, anyway.
Yeah,
Okay.
it's not much.
Good.
It's just a little bit.
Thank you. Awesome. Okay, so yes, totally. So Maisha was first, even before my son. So hello, hi, hello, Maisha, hello, Maisha, hello, Alona, hi, Michaela, hi. She's determined to keep her streak. Oh my God. I've told you that story about my brother on airplanes, right? I'm sure. Okay. Hello. So hello, Maisha. Hello, Rachel. Good afternoon, Manoj. Good afternoon, Wishi. Good afternoon, Andrew. Good afternoon, Jalen. Oh my God. Hi. Oh, okay. I get that now. Okay. Nerd. Yes, we are. Oh yeah. Like there's a surprise. Like, what did you think? We were like good at football. Hello, Rachel. I'll tell him you said hello. Hi, Catherine. Hi, my. Okay. Good afternoon, Jessica. King High, I don't even get that, but I sort of do. Oh, my other son explained the bones thing to me, sort of. Good afternoon, Ruby. Hi, Leslie. Oh, you're eating nerds. I thought you were calling us. Okay. Good afternoon, Eric. Halloween was great. Thank you. He was the Ender Dragon. You caught that. Nick, sharing is caring. Oh my God. Is it? Oh, it's not that son, actually. I mean, he does. This one actually does sort of have a channel, sort of, where we put, but like, it's like for our family. The older son is the one that I keep trying to get him to post something supportive on TikTok, but he's like worried about his reputation. Okay. Good afternoon, Elizabeth. Oh my God, Rachel. It was pretty cool. And that total credit to his mom. His mom totally made it out of like she MacGyvered it in a big way. Wait, I don't even get that. I play. Of course you play. Well, of course, some of you in this class, I'm not surprised. It's okay. Yes, he tried to be the Ender Dragon. I believe, Eric, that you have beaten the Ender Dragon. I also believe that you guys are totally janking me with the chat as usual, but I'm too tired to teach anyway. No, you have candy. Okay, that sounds creepy, Maisha, but okay. But cheat. Oh yeah, he totally cheats, Joe. He's never like literally, well, he has beaten, well, I know, whatever. Okay, I'm bringing him back. I have candy. Okay, again, slightly creepy, but okay. But only slightly, and also interesting because this is like virtual. Hello, Mark. You all hear him good. Hello, Rachel. Good afternoon, Zimin, sorry. Yes, my aquatic, yes. Don't get me started. Good afternoon. Oh my God, wait, sorry. We had a whole discussion about this. Wait, now I'm all blocked up. Wait, I'm so embarrassed. Hold on, I'm freezing. Why did this happen? I kid you not that my sister, his aunt, and I had a whole discussion about, oh my God, I used to say it correctly. And now, because there's someone else with a name like that my aunt.
It's Alea.
Thank you. All right, you knew I was going there. Thank you. I got all blocked up because my sister has a friend named Alea. Okay, Alea. I knew that. I really did. But I swear we were talking about you this weekend. And it was all good.
Yeah, okay.
No, okay. Anyway, I'm going to just move on. But thank you for saving me, sort of. I mean, definitely thank you for saving me, except that I was all right. Anyway, moving on. I'm going to start calling the fish aquatic just to show that it's like not about you. It's my problem. I'm going to start calling myself Yaverbound just to. Okay. Good afternoon, Lisa. Aquatic. Yes. John, you're done. You're done. I don't get that, but okay. You don't have what? Well, it's funny you say that. Okay. Good afternoon, Starnisha. Good afternoon, Catherine. We got Nurse Nick. No, you. What? Never. Speak for yourself. I'm a pig nerd. Oh, and now you're doing it with the chat. Okay, this is where I know what's happening now. Okay, okay. I'm going to scroll. Oh wait, did I miss? Yeah, John does ask physics text questions. Did I actually? Okay, I'm going to do physics. Yes, sorry, and I don't want to offend Rachel or anybody else. Okay. But it is good to see you guys. Sorry about that. And I'll tell you this too. Yeah, I'm partly stalling because I have too much fun with this class, and that's my problem. We're going to get to the material like right now. But one thing, just I still owe you back, as Athea pointed out last time, and I'm still hanging my head in shame, and she's totally right. I mean, she didn't like say it in a critical way, she said it in a very polite way, but I need to get stuff back to you. But one thing that I did put in your stream like a second before class, and you don't have to get it out now or do anything with it now, but just so you know, in the stream or the assignment stream or whatever of Google Classroom, there is a draft of the practice exam that's there for your perusal, for you to start doing it if you want. Don't get freaked by it. You'll see some stuff on there, like it goes in order, so you might even see stuff at the back that you're like, what? I don't even know how to do this yet. And that may be, and you'll either will know how to do it by the time we have the exam, or if we never talk about it all before the exam, then it won't be on the exam. So if you open this document, only look for the things that look even remotely familiar, and then like practice them at will. And I'm saying this in a weird, like I'm saying it. Yes. Okay. So here's the deal. Yeah. Like good question, Starnisha. And here's the deal. The main point of the practice exam is that by the time you come in Monday of next week, like there's no new homework or anything like that. The idea is like start getting ourselves prepared for this exam and stuff. Wait, okay, hold on. That sounds almost like a legitimate question. Wait, okay, hold on. This is vaguely, it's a muffin. Okay, hold on. This is like vaguely serious and I don't want to confuse people or stress them out. So So like we had this exam coming up, right? The idea behind the practice exam is that you do it on your own time. You use it for studying. It's the way you study. Like, don't like try to start reading things in the. Okay, wait. Just hang on a second. Like, because I think it was either Starnisha or someone asked like a super legitimate. Yeah, it was Starnisha asked a super legitimate question. So here's how it works. The practice exam is like sneak preview or rough draft of the actual exam. In this case, it's actually draft of draft. I'll explain that more in a moment. But it's a preview of what the exam would actually look like. And as we get closer to the exam, as I know better what the exam looks like, I will even adjust the practice exam. Like I will issue updates to it and say like, forget problem 3, that's not gonna be in your exam, but instead this, like as I like write the exam, I basically distribute it to you guys so that it's not about really surprises or anything like that. By Monday of next week, when you come in, you will have optionally already done anything you want to do or can do with the practice. I mean, you can still do it through Monday night and Tuesday, but you will have been studying by going through the practice exam. And Monday, you come in and ask questions about the practice exam, and I will answer them. I will even give answers and solutions to things on Monday. I cannot promise that I'll cover the whole thing. I cannot promise that I'll give you solutions to the whole thing. But the more you've looked at it and the more specific questions you ask, honestly, like the tighter the questions are, the more of them I can answer. And the more of the exam I will give away Monday, like for real, like the more of the solutions I'll give away. That will also happen Wednesday of next week because we do have class, right? Yeah. Right. So Monday and Wednesday of next week, I want to make this very clear. Like joking aside, like Anisha's question is the right one. So the answer is like, I won't like literally walk through the practice exam methodically, but I will answer anything and everything about the practice exam Monday and Wednesday. That's why the actual exam doesn't get distributed until Wednesday night. I will answer anything and everything. And the more the questions there are and the more specific, the tighter they are, the quicker I can answer them, the more of them I will answer. So in other words, if someone just comes in and says, can you do problem 2? That's not a great idea because you know me.
Professor?
Sorry, yeah.
Next Wednesday we won't be having class, so only Monday.
Wait, Wednesday we don't have class because we don't have school, or because of the rotation?
No, because we're the group that goes every other Wednesday now.
Yeah, you're right about that. And but didn't we miss it this Wednesday? Didn't last Wednesday? Didn't you not have class? I think.
Yeah, so we have we have class this Wednesday. So next Wednesday when we have the test, we won't have class beforehand.
I see what you're saying. Okay, really good point. Sorry, you're quite right. And I'm glad you bring that up. I might even try to rearrange things. So I might change things around. Remind me about that again this Wednesday, because that is a good point. I will probably try to rearrange things to have you have class 2 weeks in a row since you have an exam and that other class doesn't have an exam. So that's a very good, right. You're totally right. But we certainly will have class this Wednesday. So like, remind me this Wednesday about that. I think that's a legit point. Yeah, just remind me and I'll try to take care of that. And that's pretty much I can't guarantee it, but I think I can. So yeah, just remind me. What I'm trying to say to Starnisha and everybody else is, there's no secrets here. It's all a matter of time allocation. And it's all a matter too of everybody sort of budgeting my time. Because as you can all see, like I'll just blab once I get on a certain topic. So the idea is, so you don't want to walk in Monday. I mean, you don't want to walk in Monday and be like, can you teach problem 2? Because I might accidentally do that. And then I'll leave you high and dry with all the rest of the stuff. What you want to do is have worked through it enough that you have as specific questions as possible. So I can bang through a lot of stuff Monday and hopefully Wednesday. So the answer is yes, I will talk about this practice thing. It is not due to me. You don't get a score on it. If you never do it, I'll never know the difference or like care, but it is the way to study. Don't think of this practice exam as like the last thing you should do for studying after you've like read a bunch of stuff. No, just go to it when you can. But also just realize what these practice exams are, honestly. they are rough drafts for the actual exam. That means two things. One, we're, again, like I keep saying, we're trying not to surprise you with the actual exam. It's not a guessing game. It's not psych out the professor or psych out the student. That's not what it is. On the other hand, what we do is drafts, and we get closer to the exam and we like correct things and update, blah, blah, blah. So please, two things. I just put this draft in your box today so you have something to start to work with. And I do suggest that you go to it in order, like go from the beginning, because it does sort of get progressively more advanced in material. But please don't get married to this thing yet. Like date it, don't get married, meaning don't go home and try to do the whole thing tonight and then get stressed out that the last part is hard or something like that, because there will be updates to this document. Also, if there are errors or whatever, there will certainly be updates. I might swap out the last problem or something like that. So but this is to give you something to start, to get going with. And certainly the first couple of pages, I guarantee, are pretty reasonable. So it's just so that we're all not flapping in the wind, so to speak. Okay, no chatting money. Yeah, and that's fair. Like what and joking, I mean, I actually do think all the fun in this class actually does help us all learn. But I mean, I think Maisha's right. Like we should try to get sort of more serious Monday if we can, blah, 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 like what she said. Okay. Yeah. Fair enough. And I'm seeing what's in the direct chat. I totally get. No, and look, to all of you, no, I hear what's in the direct chat. Totally appreciate. Well, hold on one second. Let me take a breath. We're gonna get okay. So we'll get to your share in a second. But I also want to say to everybody, like, how can I put this? Things can get stressful in either directions. If things are too intense or too serious, it can get stressful to people, especially on Zoom and whatnot. If there's too much joking, I know that can get stressful to people too. I am aware of that. And ultimately, I just want you all to know too, I mean, ultimately, like I love this class. I mean, for real. And I do love the joking. And it is a balancing act. Like, and it is up to me ultimately. It's not like I'm making decisions when I allow the joking to allow it. And I'm doing it too, because I do think that in many ways, we will all do better in general if we're all a little bit more relaxed and a little bit more like enthusiastic or plugged in and whatnot. It is a fine balance. But I do want everybody to know too, if, for example, you're ever sitting back and thinking that the people are joking because they necessarily are on top of everything and they're going to rock and they don't even have to study and they're making it hard for the other people. And I'm saying this to everybody, just to be clear, like I've been doing this for a long time. Okay. And I struggled too, by the way. That's the other thing. Don't think that I was the person in the class, in any physics class. And I've taken a lot of physics classes, but I don't want any of you to think that I was the one just sitting there, like geniusly understanding everything and like not having to study or not having to pay attention to the professor or just like getting A's. Not at all. Like really, it's a discussion for another time. Not at all. Not at all. Like, let me say that, like, I struggled. I cared about physics, so it was worth the struggle to me, but it did not come naturally at all times. Believe me, we can all discuss this in private too, if you want another time. Believe me, I know what it feels like to struggle. And I was often pissed off at the people in the class that it seemed like everything was coming easily to them. I want to say to all of you that I do know in my heart that just because someone's joking around doesn't mean it's coming easily to them, or doesn't mean they don't care. It can often mean, the people that are joking and stuff, it can often mean that they're just as nervous about the material as those of us who are not joking, but it's a way of dealing with the nervousness. And I'm saying this to all of you, respect, like seriously. And half the time when I'm joking, it's because I'm nervous too. Okay, like no, this does not come easily or obviously to anybody. One of the put the practice exam in the box. I mean, it's not perfect. There will be changes to it and stuff, but it's so that even if we're sitting here talking and making jokes, there's something that like anybody can quietly look at their own time. It's to assure you that I'm not trying to trick you, that no one's trying to trick anybody. And again, please understand this is not a competition. When sometimes people are joking around, they're not doing it to get other people like to mess up. Well, I don't know why, but it's not gonna there's no limit to how many A's could happen in this class. Please, all of you remember that. My ideal is that everybody's helping each other get an A, which sometimes I think the joking helps with, but I don't want anybody in here to feel like, oh, this is just a classroom full of jokers who don't care or something like, so I'll get back. I mean, even right now, I know, even as I'm talking about this, you're like, get back to the material. I mean, some of you, fair enough. Just please understand that this has been going on for a long time. I mean, not COVID learning hasn't, but I've literally been doing this for a living longer than some of you have been alive. That doesn't mean I'm doing it perfectly at all, but it does mean I'm here to be sympathetic to the struggle. I had to struggle too. If I understand anything now, it's just because I've taught it so many freaking times, really, and taken it so many times. And the last thing I'm going to say about that, we will move on right now. This is a midterm. This is not the final. It is, you can even think of this as almost practice for the final. Okay. Often people will do badly on the midterm. Some people will. It is a wake-up call in a way, but very rarely does anybody in this class, and I mean this, and I particularly do like this class, and I know people in this class well at this point, partly from the joking and stuff. So, well, the midterm, wait. Well, this test is the mid, okay, wait, okay. So this I thought this was, all right, and I'll post this again if it's not clear. The midterm will be posted a week from this Wednesday, like Wednesday night, not this. I thought I think we did say this, but I'll put this in the Google Classroom if it's not clear. It'll be posted at night, Wednesday, November 10th. It will be due back right before class. Okay, cool. It'll be due back. So again, this is serious to everybody. It'll be due back right before class, Monday, the 15th. I'll put that in Google Classroom to make it clear, especially if there's like language things or anything. Remember again, please, it is a take-home test, open everything. Like, you are not only allowed to help each other, you're actually encouraged. You just, in the end, have to write out your own exam and write out only things that you understand by the time you write them down. But you are allowed to help one another get to that level of understanding. That is also why I do take some time to allow the joking and blah, 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 because I want this to be a group thing. I don't want people competing against one another in this room. Like, I mean, of course you are to some extent, no matter what. But if you hear me again, that I don't care how many A's I give out. I don't give them, I record them. But like, if you all got A's, that's a good thing, as long as like we didn't cheat and as long as the test was fair, right? So you're here to help one another. By the time you get to the test, you write out your understanding, and that's what you get graded on. But how you get to that level of understanding can be by any means, okay? So yeah, no, for real. And I have stories about that. But yes, I mean, even if Atia is like, that's what I want. And I actually have some faith that this group could do a better job with groupthink than a lot of groups do. I mean, I'm not sure if I've told you stories about it. I think I have. I have stories. But yes, all of you, and those of you who feel comfortable, those of you who don't feel comfortable. And I do hear you, those of you who are telling me like, let's move on or whatever. But physics does take all kinds of tricks and like self-confidences to do. Oh, what I was going to say though to all of you is, I don't know okay, there are some people, I'm getting to know some of you fairly well, partly from the joking, partly from the direct chats, partly from people staying right afterwards and asking questions and stuff like that. I actually know some of you fairly well, especially for like remote learning. That is to everybody's benefit. That means both I can adjust like my teaching to meet your needs. Also, it means I can write recommendations later. Also, it means if you're right on the borderline of 2 grades, of course, you're going to get the benefit of the doubt if you've like shown engagement and shown personality and all of that is like really true. And let me tell you, I know any one of you who's ever sent me a direct chat at all, expressing any concern, any one of you, I know you fairly well at this point, and I can tell you, any one of you who's ever shown a concern of any kind or has a concern, I could tell you that I know you guys well enough to know that you're the kind of people that even if you do badly on the midterm, which does happen, I'm not going to lie. I mean, it can happen that you could do badly on the midterm. there are still enough things in place, enough buffers, enough other opportunities, enough lab scores, homework scores, final exam, that even if you do, it's very rare that someone who does badly on the midterm seals their deal and then can't pass the class or can't get like a high grade in the class. Maybe it's possible to do badly enough on the midterm to preclude yourself from getting an A. Like that can happen because there's just a midterm and a final. Yeah. I mean, but there's also your lab grades and all that. But it's pretty, but in other words, the point of the midterm is opportunity one to put some major numbers into your grade and beef up your grade and get a good grade at the end. But I don't want anybody overly freaking out about this midterm. Your fate does not get sealed like boom due to this midterm alone. I'm okay. Like I want to get serious and study for it with all of you and like start preparing again, do the material. But like just try to be intense about it. Don't try to be overly stressed about it. And I mean that. And I've been there. Okay, I'm gonna come, but I'm just trying to say that to everybody. Again, I like this group a lot. And I think in the end, this group should be able to do well on stuff. But even if you don't feel like you always are like liking what the group is doing, that does not mean you'll be left out of the cold or something like that, for real. All right, I'm gonna take a breath for a second and get back to the material. Hold on. But yeah, you should have a group chat for the midterm. Okay, hold on. Let me just take a breath and get.
Professor?
Yes.
So the midterm we must upload in the PDF file or other any kind of file is acceptable.
Wait. Well, I'm sorry.
So the midterm assignment we need to upload in the PDF file or other file is also acceptable.
Yes. Wait. If you're asking about the actual real midterm, you'll upload it as a PDF to Google Classroom. That's right. Is that what you're asking, or are you saying something about that?
Oh, I'm just asking for the midterm. For the midterm, we must upload in the PDF form or other form is also okay.
Oh, okay. PDF is ideal. Google Doc is fine. Also, those two would be the best, either PDF or Google Doc. It could be, I suppose, it could be a Word document. Those usually work, but sometimes they don't. But I'll tell you what it should not be. Okay, PDF is the best. Google Doc is totally fine also. PDF or Google Doc, both totally fine. Word could be okay, but what it should be is one file with all the pages in order. What it should not be is like many JPEGs or something like that. That would be a problem. And also what would be a problem, and also like unidentified file type or unusual file type or even HTML or something, even that's very risky and not a great idea. If you can please do a PDF or Google Doc, one file for the whole thing. That's the best. Is that okay? You tell me if that's clear. Does that make?
Yes, understand.
Okay, great. All right, thank you. Okay, great, thank you. And all these questions are. Wait, can it be? Yeah, and so Rachel, and look, right. Hopefully to everybody. I mean, I know. So we're maybe not doing physics at the moment, but these are very real questions, and I am here to answer them. And and you got it. All right, thank you, Rachel. That's awesome. And you guys get points for closing the conversation. Like these conversations are totally legit. Or these questions, okay? Again, like you got to know. You can tell. I find exams stressful, even as the freaking teacher. I find them stressful. I found them super stressful when I was a student. I can't make them zero stress. They just are stressful. But I can assure all you guys that I'm not interested in cultivating the stress. In my ideal world, if we could have the exam with zero stress, anything I could do to do that is what I would do. And that's what I'm trying. So therefore, what I'm saying is, if you have a bunch of questions like this, like I want to answer them. But the main thing I can tell you all is the main purpose of the practice exam that's now in your stream, even if I change some of the content, and I'll warn you when I do. I mean, I will change it to make it, if I make a change to that, it's because I'm saying, oh, your actual exam is going to look more like this. It's as I get closer to the actual exam, I'm making those adjustments right into your practice, okay? And the main thing you can get from the practice is all these kinds of like format questions or like style questions, like just so you can expect, so you know what it like looks like and feels like. That is it. I mean, that, you know, the equation sheet at the front, and I don't even remember, right, but you'll probably on your actual exam, you'll probably have a choice. Like it'll probably be like do 3 out of 4 of these problems or something like that. Okay. All right. So I'm gonna look at the chat and I'll move on to sorry. Yeah. Right. So to Ruby's question, and frankly, I'm very glad that Ruby asked this, but also I'm glad she put it in the public chat. Like the answer is yes. You're going to treat it like it's just one big homework assignment. You write out. Sorry. Yeah. The more, right. This is like, and so to the direct chat person, yes, like the exam is like one big homework assignment. And it literally, the only difference is like the grade counts more, but totally anything you've ever done for homework is what you're doing. So yeah, you write out things on blank pieces of paper. You treat blank pieces of paper as though they were a blue book, like for real. You treat just your own blank white pieces of paper as though they were a blue book. You write out and you write like question 1, like what, and you make a diagram and like what, make a diagram. And then you're like, the question is, what is the velocity? Sorry, you write out a diagram and you write like the facts, like there's a ball over here, blah, blah, blah. It's going up like that. What is the velocity at time equals 3? And then you show the work and then you circle the, okay, cool. And then you circle the answer. Yeah. And again, and the more thoroughly you do that, and again to everybody, and hopefully this is helpful, not like a waste of your time. You don't copy and paste my questions. You literally, on white pieces of paper, you literally act like a blue book, like you're just providing all your responses. But in there, you make the questions super clear in your own words. And that is part of the exercise. That really is part of the exercise. Like, first of all, make it as easy to grade as possible. Like make it in your standard. If you're ever wondering, like, do I have to include this or should I do that? Just just imagine that I'm grading your exam without looking at the original exam. Like that's the deal. Like I'm trying to grade your exam without any other documents in front of me, I'm trying to grade your exam as efficiently and objectively as possible without having to flip to anything else or check. Right. So you're trying to give me everything you can on those pieces of paper to make it absolutely clear what's going on when it's going on. Right. And you're showing all work for sure, but you're not like giving me an answer and then giving me like on the side, like scratch work. You're like doing it out, if you follow me, which might mean in some of your cases that you actually, hopefully it will mean that you'll do a bunch of scratch work somewhere else. And then once you're confident of all your work and confident of the steps, you'll like write it out neatly and you'll turn it in. You have 5 days to do that. I mean, it kind of is almost more like doing an essay assignment or something, except by hand. And again, you can check your answers with other people. Like that won't be cheating, but just by the end, be so confident of it that you can present everything in a totally organized, clear, thorough manner. If that, okay. Okay. And thank you for saying that you got it in the direct chat. Okay. Okay. Now we still have class time today and we still have class on Wednesday. I mean, we still have some classes to get through before then. So, okay. So I am still going to do some material here. And I'm going to move on and do a little bit of oh yeah, and to answer your question, that thing at the top is supposed to be a star, and the thing at the bottom is supposed to be a cloud, which always ends up looking like a deformed human being or perhaps a muffin, but it's supposed to be like a star character and a cloud character. It's supposed to be sort of like lightning and thunder-ish. It's supposed to be a dialogue. It's supposed to represent that physics is an ongoing dialogue between two voices, you and your friend, you and me and you. It's never just an inner monologue. Like that will just, your brain will eat itself. Okay. Oh, thank you. Oh, I appreciate it. But I know the cloud looks like a deformed, gross human being. Anyway, but thank you. Okay, but I appreciate it. All right, what do we do? Oh yeah, good.
Professor, I know you're writing about lab 3 and 4. We're in the beginning of lab 3, the graph. The
Perfect.
drew the directions on the graphing paper, and we haven't yet started or opened lab 4.
Absolutely right. You're absolutely right. Sorry, but perfect. You're absolutely right. And then I will restrict my comments to lab 3. You're totally right. And I knew that, but I forgot that. This will be 100% about a lab 3 than what I'm going to say now. I mean, it'll ultimately help you with lab 4 too, but you're absolutely right. Thank you, sir. And that will not mess you up on the exam, I promise. But yes, so you started the business with the graph paper in lab 3, right? You started it. Yes. Okay. All right. So I'm going to give you some insight into that right now. I don't want to give, wait, so you have not gotten to the, oh, whoa, what's happening? Sorry, something's happening to my connection. Hold on 1 second. Wait, okay, let me actually make sure so I don't give anything away. You started it, but you have not, so you're all trying to get you're trying to put your directions together and maximize how far you get from the island or from the center of the graph paper. And you have not finished that process yet. Is that correct? You started as 2. Yes. Okay.
Nope, that's all we've done so far.
Okay. Great. It's 2 next week. Okay. So this is then I think what I'm going to say right now is actually going to help you. I think it'll probably help it make it clearer. Hopefully you'll stop me if it doesn't, but it'll also help us put the material together. So here we go. So what? Oh, let me just read this. So what this says, and you're right. This will also ultimately. This will ultimately help with lab 4 too. But forget I even mentioned lab 4. Forget lab 4. This is about lab 3. And what you have in lab 3, the whole point of lab 3 is the, in a way, introduction to two-dimensional motion. Now, something I said in the video last week, but I'm going to say clearly now, like I understand I haven't said it to you directly, I've said it in the video, is remember Galileo's principle of relativity. We have a number of forms of it so far. We have form 1, form 2, form 3. They all come down to the same idea. Well, they're all different versions of the same idea, which is the laws of physics, whatever they are, the laws of physics are the same at all constant velocities. Like that's the principle. We have different ways of saying it. We have the first form, we have the second form, the third form. What they all ultimately, well, I'll say it quickly now. Like the first form is just that. And you have this in your notes from weeks ago, but the laws of physics, whatever they are the same at all constant velocities, whether you're going 100 miles an hour to the east, or you're going 3,000 miles an hour to the west, or you're going 0 miles an hour, the laws of physics are the same. So what? So what that means is form number two said, well, if the law, form number two said, no experiment could ever be designed or performed to measure the absolute velocity of a single object, of a solitary object, like through space. Let me say that again carefully. I know I've said it a million times before in some ways, but let me say it more clearly again now. I'm not saying we can never measure velocity. Of course, physics is all about velocity. We can measure velocity, and we can do experiments to measure velocity. But what we can never do, according to form number one, what we can never do is do an experiment to measure the velocity of one object by itself. We cannot find out how fast an object is like actually going or absolutely going or singularly going just through space. All we can ever do is find out how fast one object is going compared to another object. And the reason for that is form number one. Form number one says that, and again, I know I've said this before, I'm just trying to review here for a second. Form number one says that the laws of physics are the same, whatever velocity you're going, right? Whether you're in an airplane that's parked on the ground, or like on a runway, or you're in an airplane that's going past the clouds and past the earth at 500 miles an hour, either way, the laws are the same, which is why in an airplane, as long as it's going constant velocity. And that's why when an airplane is going like 500 miles an hour at constant speed of 500 miles an hour, you know, over the oceans and over the lands, like as long as it's going at a constant speed and direction, you can walk around the airplane, you can act all normal, you can drink your drink, you can chill out and go to sleep, like it, and everything next to you just sits stably next to you, right? Because the laws are all the same. It's just like a little mini laboratory or a little mini planet Earth or a mini driveway. And it's not because of some cool contraption inside that makes it magical. It's the same reason that things feel normal inside an elevator or on an escalator or in a subway train when it's not bumping or lurching or speeding up or whatever. That the laws are the same at all speeds then means all you can do at best in that airplane, you can look out the window and see that clouds are going past you like this. Or you can look out the window and see that the land below you is like going back like this. But if you ask yourself, wait, well, let's say the clouds, if you say to yourself, are the clouds going like that, or am I going past the clouds? Or similarly, like you're in a car on a highway and you just wake up and you suddenly a truck next to you and you're in all this traffic and a truck next to you like starts backing up. And you ask yourself, oh my God, wait, am I moving forward or is the truck backing up? Like which one is actually happening, right? Which people do ask themselves all the time, or they think they resolve all the time. What form number two is saying, there's no, you can't do an experiment to find out which one is actually happening. Because no matter what you would do, no matter which one is actually happening, whether you're moving at zero or moving at some other speed, any experiment you would do would work out to the same result because the laws are the same, no matter what speed and direction you're going. So any experiment you would try to do to find out what's actually happening, you can't find anything out because simplest example of all, like if you just tried to invoke gravity and you just tried to like drop something and you're like, oh, if I was just sitting here, if I were just sitting still and I dropped something, it would like land directly below my hand. It would fall straight down and it would land at 9.8 meters per second squared and it would land at my feet. So you might think to yourself, okay, so I'm going to drop something. And then since I know if I were sitting still, the thing would drop directly below my hand, fall in a straight vertical line and land at my feet. You might say to yourself, so I'm going to do that. And then if the thing lands at my feet, then I guess I'm sitting still. But no, that won't work, because no matter what speed you're going, the laws of physics are the same. No matter how fast you're going, as long as you're going at constant speed, the thing will just drop in a straight line and land at your feet, like things do on airplanes or in elevators or on escalators, right? Like anything you do on an escalator or in an elevator or on an airplane, as long as you're going constant speed, anything you do is like normal. All experiments work out to the same results because all the laws are the same. So form number 2 says you can know that you're moving past that thing, and you can even know that you're moving past that thing at 40 miles an hour, or that thing is moving past you at 40 miles an hour. But you can't know what's actually happening through space. You cannot experimentally measure the absolute velocity of a single object in space. All you can do is measure velocities as comparisons, as relations. That's what form number 2 says. So then form number 3 says, well, if that's true, and we're in experimental science, we're science here, we're not just philosophy or something, we're science. So if there's no experiment that could ever be done to measure the absolute velocity of a single object, if experiments could only reveal relational velocities, then according to physics, from here on in, from there on in, velocity is only a relational measurement. It's only a relational idea. It's always a comparison. There is no such thing as the absolute velocity through space of a single object. There are only comparisons. The laws of physics are the same at all velocities. Like every velocity then needs to be in reference to some other object. The velocity of any one object has to be in reference to the velocity of another object. That means we always have to choose what we're referring things to. We always have to choose a coordinate system. We always have to say, okay, I'm comparing things to, I'm going to call that thing over there 0, and I'm asking what's going on. Like I'm comparing things to the sun. I'm using the sun as a reference frame. So then I would say the Earth is moving 65,000 miles an hour. Or if I use the Earth as a reference frame, then I would say that me standing on the Earth right now, I'm going 0 miles an hour. And I'm saying the sun goes 65,000 miles an hour past us. Every physics problem, we have to choose a reference frame, a coordinate system, and make all of our measurements according to that. And if we choose a different reference frame or a different coordinate system, then our measurements will be different and all of our numbers are going to be different. Okay, now what does that have to do with anything? That's technically what I just said was like review of a concept, but it's a concept that like stays with us for the rest of physics forever. But now I'm going to say there's another extension of that idea. Like what I just mentioned somewhat quickly was form number 1, form number 2, and form number 3 of that principle. Now I'm going to say, I mean, again, I said this in a video last week, but I'm going to say it right now. I'm going to tell you something called form number 3.5. Kind of not coincidentally, it sort of helps us right in between lab 3 and lab 4. Form number 3.5, what it says is every two-dimensional problem in physics, every two-dimensional problem or experiment or phenomenon or whatever is in fact two one-dimensional problems occurring simultaneously yet independently. Now I'm saying, I mean, like every other point in physics, it sort of sounds obvious maybe in a way once I say it, but it's powerful. I'm saying like, just like I'm saying that if we always have to pick a coordinate system, if every velocity we measure or every problem that we do or every set of quantities that we have to get is all have to be relative to, compared to, based on some coordinate system, like we say the sun is 0 and our x-axis is going through here and our y-axis is going through here or something like that. If we have to choose our coordinate system and then get all of our measurements in accordance with that, if you think about it, well, yeah, and if you accept the idea that one coordinate system is just as good as another, as long as they're both constant velocity, as long as a coordinate system is not accelerated, as long as it's going the same speed and direction. If one coordinate system is just as good as another, and if the laws are the same in all coordinate systems, well, if you think about it, the simplest possible coordinate system is just an axis, right? Like all the problems we were doing right at the beginning of the semester were all along a number line. They were all in effect on an x-axis. And all the equations we got, this is important, all the equations that we've gotten so far, all the equations that are like on the first exam, the 5 equations, like v equals x minus x naught over t, a equals v minus v naught over t, v bar equals v naught plus v over 2, x equals 1/2 at squared plus v naught t, and then x equals v squared minus v naught squared over 2a. Those 5 equations, those all assume one axis of space. All those 5 equations that we have so far are about one dimension of space. They're about one-dimensional motion. They all assume one axis. What I'm saying is that there's no objective x-axis in the universe. Like, you choose your axis. You could say, this is my x-axis and I'm going to do physics here. Or you could say, I'm going to do physics along this axis. And all those equations apply. They apply to one axis at a time. But every axis is its own little coordinate system. The laws of physics hold true over each axis the same as each other axis. Like, we don't make a new set of laws for the z-axis or something like that. The one-dimensional equations that we have are all true in one dimension at a time. So if anything ever happens, so we're not going to get new equations as we expand our understanding into like a more and more realistic world. Like, everything we've been looking at so far has just been like a line. The world of actual space seems to be 3-dimensional. Like, I'm aware of that. I'm not saying that we're trying to lie to ourselves as scientists. I'm not saying that we're going to pretend for the rest of our lives that there's only one dimension of space in the world. There is 3 dimensions of space, it seems, in the world. I mean, there's this, and there's this, right? What I'm saying is we have all the equations we need to figure out what's happening in any one of those dimensions at a time. If something happens in more than one dimension at a time, like if there's a 2-dimensional motion, which is really what you're trying to study in lab 3, you're trying to study like some person or something that's like walking off an island, like in diagonal ways, not just north, not just south, but like, and not just east or not just west, but like northeast, southwest, right? You're looking at 2-dimensional motion in lab 3. The key principle that I'm here to say is exactly what it says on the piece of paper right here, I mean on the screen. A 2-dimensional situation, it's really important to understand. A 2-dimensional situation is just 2 one-dimensional situations happening at the same time, but independently of each other. That's the key insight. I'm going to show you an example like in 1 second. I mean, it's an example very much like your lab 3. But I'm saying, like, if someone walks northeast, what that really means is they're walking some amount east while they walk some amount north. They're doing both at the same time, but the two motions don't affect each other. They don't interact with each other. It's literally like 2 separated physics problems happening independently of each other, but by coincidence at the same time. One last way, I'm going to show you an example, okay? But one last way I'm trying to put this is the equations that you know so far, if you feel comfortable with any of them, hopefully eventually you feel comfortable with all of them. But if you feel comfortable with any of the equations that you have so far, what I'm trying to say is they apply to the x-axis, they independently apply to the y-axis. If anything were to happen in both axes at the same time, or even in a cube, if anything were to happen in real space, those equations would still apply, and you would just apply them to one dimension at a time, and then just recognize that the dimensions are happening at the same time. Let me show you what I mean. And this is like Okay, I'm going to do this. Isn't a question for you. I mean, this is a rhetorical question. I'm going to answer this, of course. And I know we have 20 minutes. I think that'll be a perfect amount of time to do this. This is like a little slice out of your lab 3. Like I understand the questions in lab 3, or I know what lab 3 is, believe me. And I don't want to give away the thing, but I also want to help you. And also I think once you're all done with it, you sort of do get asked a question sort of like this when you have to do the report and the analysis. So hopefully this will help. So I'm going to say things about, I'm going to answer this question that I've just asked, and hopefully you'll see in what I'm saying things that might help you with lab 3 and vice versa. But here's my point. Like what I want to add to displacements to get a total amount of displacement, just like we were doing in the original number line assignment. We were walking here and then we were walking there and we were finding out where do we actually end up. That's what I want to do. Like what I literally want to know here is how far, I want to know my total displacement if I add these two displacements together, which really means what I really want to, if you remember that displacement means distance and direction. What I'm really asking in this problem right here, it's just an example problem, obviously, and it's new. I'm like doing it right now. But what I'm really asking here is if I walk 2 meters due east, like at 0 degrees east, and then I walk 3 meters at 30 degrees of northeast, what I really want to know is how far away and in precisely what direction do I end up compared to my initial position? I'm really asking how far away and in what direction is my final position compared to my initial position? That's what this is really asking. And it's just asking that I add up two displacements, but it's asking that I do it in two-dimensional space, right? Okay, and I'm going to do it. I'm not asking you to do this right now. I'm about to do it. Oh, okay, so that's a really good thought. Here's my point. I'm glad that John just put it. And by the way, so John should totally get points for participating for what he just did. He's also going to get 11 points because with all due respect, I'm going to say it's a great contribution he just made, but it's actually not right. And this is what I want to show you. Like it's a really good thought, but the reason I have to put a little work in, so oh, sorry, I don't know if you saw in the chat. That's also a really good thought, what's in the direct chat. And that's also, you totally get points for putting it in. I'm going to say you also get 11 points for it not being exactly right, but you're both following what I'm saying, which is good. Let me show you what's going on. Like if I draw a diagram of this, first of all, if I draw, like if I go 2 meters, oops, sorry. Say I go 2 meters due east, right? So this is 2. And then, so I started here, let's say this is like my initial position where this like little star is. So I go 2. Then from where I ended up, so that's like my initial position, and this is at the end of the arrow is my intermediary position. Then from there, I go like 3, which is a much longer arrow. Well, not much longer, but it's a longer arrow, right? So I'm sort of vaguely trying to draw this to scale. And I draw, and that one was supposed to be like northeast. What I'm really asking here, if you think about it, I'm really asking how long is that red arrow and in what direction is it pointing it? And I am asking, but I'm going to solve it. I don't think any of us, including me, I don't think we could actually get the answer in our head. Is what I'm saying. Like, okay, let me start with John's very reasonable answer. John said 5. Now 5 looks totally reasonable, like 2 + 3 is 5, of course. But if you think about it, like, and there's something to the idea of 5. What 5 is the total distance that I walked. I walked 2, and that, so I mean, John's not crazy, and neither is direct chat person that she just put, or he just put in something. There's nothing crazy about saying 5. But yeah, I'm going to have to use trig. Good deal, Mark. Yes, I'm going to have to use trig, and I'm going to have to be, and I'm going to be a little bit careful at the time. I know we have 15 minutes left. And I'm going to have to use things like the Pythagorean theorem and SOHCAHTOA. I'm going to have to use some trig, and these are, well, right. Okay, very good. This is good. And I love what you guys are saying, and clearly you are all like right there with me. I'm going to be a little bit, because I'm watching the time and I want to make sure to get this answer to all of you. I'm being a little bit lectury, I apologize, but here's the deal. We do have to do something with triangles or something, because 5 was a smart thing to say. 5 is a total distance. Well, I think because John just put another thing, I think he knows, but 5 is a total distance that I walked. but the total displacement, like how far I literally end up, like final position minus initial position, the actual length of that red arrow is going to have to involve some kind of trigger geometry or something. Like I think it's going to be less than 5, right? Because I walked 2 in a certain direction, and then I did not walk 3 in that same direction. I walked 3 in some other direction, and direction matters here, and it particularly matters because I'm in 2 dimensions now, right? So I'm going to get something other than 5, and I'm going to say right now too, I want to do a method that will work. I want to do a method of adding these displacements, what are technically called these displacement vectors. Remember, vector is a quantity with magnitude and direction. I want some kind of method or way of adding these displacements that will always work, like whether I have 2 or 3 or 5 displacements that I'm adding, or 2 or 3 or 5 vector quantities that I'm adding, and whether they look like they're organized in some nice triangle or not. I want a method that will always work. And here's the deal. A method that will always work will involve right triangles. You're right. I don't see an obvious right triangle right here. Like John's totally right to point that out. I don't see an obvious right triangle staring me in the face. But if I'm right, good. Someone else in the direct chat just said something about Pythagorean theorem. Here's the thing I want to say to everybody. Pythagorean theorem and SOHCAHTOA is what we're going to use. But let me make it absolutely clear to any of you who are like really super paying attention, which you are. Pythagorean theorem and SOHCAHTOA are about right triangles. I don't obviously see a right triangle right here staring me in the face. Like this is not, okay. I'm going to, yes. Let me just like talk for a second. If you don't, awesome. I am going to use right triangle methods, even if we don't see an obvious right triangle here. And here's the reason, because there's always a right angle between the x-axis and the y-axis. Axes are always at right angles. And my principle here is that even though I'm doing things in 2 dimensions, what's really happening is 2 sets of 1-dimensional things are happening at the same time, yet independently. Here's what I'm going to do. I'm going to break it. And bear with me if you don't, I beg your indulgence because I know there's only 12 minutes left. So I sort of want to like do this and make it clear to you if I can in that 12 minutes. So I beg your pardon if I don't address all the chat things, but okay, here's what we're going to do somewhat quickly. We're going to do something called, this is called what we're doing here is adding vectors, right? Remember, vectors are quantities of magnitude and direction. But now we're starting to take vectors very seriously here for the first time. We're taking magnitude and direction seriously in higher dimensions, in like 2 dimensions. We're going to add up these 2-dimensional vectors. The way we're going to do it is by the component method. We're going to take each vector and break it up into 2 1-dimensional components. We're going to look at each 2-dimensional motion as 2 1D motions that are occurring independently yet simultaneously, or simultaneously yet independently. And so we're going to literally break the world up into an X world, into an X world, into a Y world, and say that we know physics in each 1-dimensional world. It just happens to be 2 worlds that are happening at the same time. Here's what I mean. And again, I am watching the clock. I know it's 4:10. Here's what I mean. Like I'm literally going to break up the world into like an X axis or an X dimension or an X coordinate system and a Y coordinate system. I'm going to break it up like first we went 2 directly to the east, right? We went 2 directly to the east. And let's just assume, I'm going to assume from now, I'm going to make my coordinate system. I'm going to assume anything going to the east is positive, and anything to the west is negative. And simultaneously, yet independently, I'm going to assume that anything going north is positive and anything going south is negative, just like you might, I mean, and I could do it other ways, but I think that's a convenient way to do it. So the first vector takes me 2 directly to the east. So it takes me 2 to the east, and it doesn't take me at all to the north or the south, right? The second vector, a little more tricky. The second vector, so I didn't have to do much there. The second vector looked like this, right? It was 3 at 30 degrees northeast. By the way, sidebar, northeast means north of east. Southwest means south of west. It means, like, imagine an eastward pointing reference axis, so to speak. Northeast means that 30 degrees northeast means you opened up 30 degrees north of that x-axis, just to be clear. So when I did that, when I went 3, if you think about it, change that color. Sorry. So when I go 3 to the northeast, if you think about it, here's where the trick comes in. Here's where the Pythagorean theorem and SOHCAHTOA and all that, as you guys were totally, like, intelligently surmising. I'm just taking that individual vector, that individual second thing that happened. Like, I'm not relating it to anything else. I'm just saying, when I went 3 meters to the northeast, what I really did was I went some amount east and I went some amount north. North and east are always at right angles to each other. The X and Y axis are always perpendicular. So what I'm doing is I'm taking every individual vector, every individual piece of two-dimensional motion, and I'm turning it into its own right triangle. Like the first one, in principle, I would have done that too, but the first one's so easy, like I sort of didn't have to do it. But this one, 3 meters to 30 degrees northeast, I'm saying that is its own little right triangle. To go 30 meters at 30 degrees northeast is to go some amount east and then go some amount north. How much? Well, this is where SOHCAHTOA comes in, and you do need to know SOHCAHTOA. We can review this next class again if you want. But you know, SOHCAHTOA, sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, tangent equals opposite over adjacent. And yes, as Mark and some other people point out, that only applies to right triangles. But I definitely have a right triangle here because I'm dividing this random displacement into a y-axis piece component and an x-axis component. Well, if the cosine of 30 degrees equals adjacent over hypotenuse, then the adjacent equals hypotenuse times cosine, right? For all time, like that's true. So I'm going to say the adjacent to the 30, the x component of this, what this literally is right here is 3 cosine, 3 times cosine of 30 degrees. That's the length of that side, right? And the length of the, I mean, you might have to check that with yourself, but like the length of that adjacent side, the x side, is 3 times cosine 30. The length of the opposite side is 3 sine 30. Now, you may or may not know your sines and cosines very well at this point. You might want to get used to them again. But these are just numbers on your calculator, if nothing else. And by the way, you're allowed to use a calculator on the exam, right? I mean, you're allowed to use anything. So these are just numbers on your calculator. For this, I would be in degree mode in your calculator if I would. And these are just numbers, like 3 times sine of 30. You may not know this or may not, but that means 3 times 1/2. You could check me on that. So I'm saying this second vector brings me 1.5 to the north. Where did I get 1.5? It's 3 times 0.5, 1.5. The other one, the x, is 0.866. Cosine of 30 degrees is like 0.866 times 3 is like 2.6 something, right? So now, and we're just about done. I know that, oh, there's like 5 minutes left. So what I'm, right, you see what I'm doing, right? The first vector just brought me 2 to the east and nothing to the north. The second vector brought me 2.6, and you can check my math. I believe 3 cosine 30 is about 2.6. Check my math if I'm wrong. I'll check in the chat in a second if I'm wrong about that. It brought me like 2.6 to the east. 1.5. Wait, 1.5 for this, right? And but for this part, you what do you get for? Well, I'll check and see. Is that what you? I'm not sure. Starnisha, I mean, thank you. I'm not sure if you're agreeing or disagreeing.
No, I'm asking where did you get 1.5 for y?
So I'm saying that is 3 times the sine of 30, because the sine of 30, and you could check this on a calculator, the sine of 30 degrees is 1/2 is 0.5. So it's 3 times 0.5, which is 1.5. Does that make?
Oh, yes, I think I have to change my calculator. Okay.
Okay, cool. All right. And the other one, I think someone should check me out, but I'm glad she asked. I'm glad you asked, Arnisha. So I'm saying now, like, we're trying to add these two motions up. I'm saying the way to add them is at X and Y is how far we got moving, how far we were displaced in the X-axis versus in the Y-axis, like east and west. I mean, like east and north, in other words. Like ultimately what I'm saying is here, let me just finish it. I'll try to answer these questions. Let me just finish it so everybody can look at something. I'm saying at the end of the day, I'm going to turn the page for a minute. Don't get freaked out, please, but we still have 4 minutes. So we'll make this all clear. But I'm saying, in fact, let me just. Okay, I'm saying. I'm going to turn the page. I'm saying at the end of the day, if you really think about what happened here, at the end of the day, we went hold on, I'm just gonna. Yeah, okay. I'm saying, and we have 3 minutes left. I'm saying if we go like this, if we went if you go 2 to the east and then you go 3 to 30 degrees to the northeast, what you really did, yes, that's right, John. Yes, that's right. And I'm going to do that. Or yes, that's right. That's right. And I'm going to do that because I have 2 minutes, but totally yes. So you're following. I'm saying if you go 2 to the east and then you go 3 at 30 degrees to the northeast, then really, as long as you break everything up, if you look at that as something happening to the east and west, something happening in the x-axis, while something independently is happening in the y-axis, if you just break everything up into 2 worlds, like a y-axis world and an x-axis world, you can realize that really what happened is you walked 2 to the east, then you walked 2.6, like this is 2.6 to the east. You also walked 0 to the north, and then you walked 2.6, and then you walked 1.5 to the north. So if you add all those up independently, but simultaneously, the situation is that you went 4.6 to the east. It's as though you went 4.6 to the east and then went 1.5 to the north. In other words, the total distance is, like John said, it is the Pythagorean theorem. It's the square root of 4.6 squared plus 1.5 squared, which is approximately, and we're just about to end. We're just about done, and we're just about to end. Yeah, which is about 4.8 meters. And this angle here, if you think about a tangent of, now I'm doing this fast, you might have to think about this after, and we'll keep talking about this Wednesday, but the tangent of that angle equals the opposite over the adjacent. So the angle equals the inverse tangent, the arctangent, if you like, of opposite over adjacent, which is, and then we're going to, and obviously if you have to go right now, then go, but we are just about done. This is, yeah, about 18. What I'm saying is the final answer to this little example problem, in this little example problem where we went 2 And then, sorry, yeah, we went 2 and then we went 3 at a funny angle. At the end of the day, what did we do? We went about 4.8 at an angle of 18 degrees northeast. Why? How? Because I took every two-dimensional motion and I broke it up into 2 simultaneous yet independent one-dimensional motions. That's like the background of what's really happening in lab 3. Whatever you're doing with those directions, each one of them is two-dimensional. You can, yeah, if you did a different, I'm going to look in the chat in a second, but I'm going to say to everybody, that's it for today. You can totally go. We'll keep talking about this Wednesday. I'm going to stay for a second and answer questions that I see in the chat and stuff like that, but you can go. Thank you guys very much for being so patient. Okay, so let me just answer these questions, but goodbye. Thank you. But great. Okay, so direct chat person, if you, yes, have a nice day. Awesome, awesome. If you used a different thing, as long as it wasn't a coincidence, then great. Just, but you should, at least one person put in the direct chat that they did something different, but they got the right answer. That's cool. But you should know my way of doing it too, because my way will always work. And I don't, or if you can show me what you did, I could show if it's equivalent or not, but make sure you know this way as well. But okay, cool. All right. So let me just look at it. But good, thank you guys. Let me just look in the chat for the questions. All right, hold on. I mean, for the, yeah, so John was right at 6. Oh, we forgot the square root. Fine, fine. Wait, let me just, oh, and I'll turn off the, hold on, turn it off.